Good afternoon, everyone. Welcome to the November 2nd SEQP and related events Zoom call for Hamside. Let's take a quick look at our agenda. There's a lot of stuff on it. We'll see how much we get through. Let's see here. Yep, just real briefly, since I got at the top of the list, we've got 219 logs now for the SEQP. About 10 have come in since last week, and a couple of more entries for the Gladstone Signal Spotting Challenge. And that the log window is open until like November 11th, and there's a couple of days, a soft window on the back side of that we don't advertise, but we'll let logs sneak in, which is great. Ed, I don't know that we've got much from you, but we'll give you a chance for a little bit.
No, I've just got I guess we had one placement last week on Hackaday, which Mackenzie put up very, very quickly. I did a presentation last night to the Port City, New Hampshire club, which I thought was a really fun group. Okay, they're about 100 people, and they've got a nice budget, so it's a really rich club, I think. But it was kind of just a couple of observations. Was one. With one eclipse gone and another one coming up, it had a different flow, where you sort of, post dating. I mean, maybe we should think about maybe making a couple of revisions, that sort of, plays a little bit more in terms of things that we might have learned, from October, but really place a greater emphasis on getting you to participate in April. The other piece that came up was that they're very, very interested in doing the April event as a public event. And they talked about maybe going in and doing a couple of school presentations and see how that plays out as to what really constitutes a public event. And it sort of got me thinking is that, we had submitted some pieces, I think, Gary, you'll remember, to Mike Walters when we brainstormed a little bit in terms of ideas a couple of months ago. And maybe one thing that may come out of this is maybe just like a quick one sheet is that if you're thinking about doing the QSO party as a public event, here are some things to think about, or maybe some ideas that we might be able to brainstorm. So it would help us, sort of get the word out, and get other clubs to participate as well too. So just a real quick thought, and that's all I have for this week. So.
All right, Ed, thanks. No, you're right. It was probably sometime late spring, early summer. Ward and others helped us come up with a list of club activities, and we never we kind of ran out of time to follow up on that. But that's something I should put back in the minutes and bring that forward. And so if you're a club, like Ward said, you go to the website, you click on a page, and boom, here's ideas for things you can do, whether public or private, whatever. Yep. But that's something we need to finish up. So I'll dig that back out. I know I've got that recorded somewhere. We had a whole page full of ideas.
Yeah, and I'll dig up the piece that we sent over to Mike. So,
okay, good. Speaking of club and publicity and whatnot, Nathaniel had a bit of a brainstorm this morning about putting out a press release regarding our October event, and I would like to see that happen too, because some of the material from that can get used in other places, like updating our standard presentation. Because I'm obviously big on doing things once and using them many times. So, Nathaniel, is there anything else you want to say about your press release idea?
Well, I think as it turns out, I have to give some public presentations this coming Tuesday and Wednesday. The first one on Tuesday is the Lackawanna Astronomical Society. So Mary Lou might like that. That's going to be at the observatory at Keystone College, which I've never been to, but apparently it's very nice and they have a dome and everything. So I'll be in person, and then I'll be doing a Zoom presentation for Jay Schwartz's club, WB8 SBI, on Wednesday evening. And I wanted to include in those presentations slides that show some results that we've had from the October eclipse. So this speaks to exactly what Ed was saying. We're revising the presentation. So I want to change mine to be like, yes, here's what the eclipse is. And look, we just had the October eclipse. Here's some of the results. And this is really cool from October. We haven't finished analyzing it, but you can really see it here. We want you to participate in April too. So I think in terms of the press release, we can kind of work the press release and the presentation at the same time, because we can use the presentation to have like one slide kind of featuring each of the different projects that are going on. So I have There's some really nice figures that Bill Engelke has come up with, showing the grape digital RF data. We have some nice figures from, I know Jonathan Rizzo's putting together a slide on VLF. Steve Serwin's going to work up some figures for the TDOA. We're going to hear from Nick Hall-Patch today to see if there's anything from the AM receive project. We have some nice things from the Grape FL Digi project. Gwen Griffiths and Rob Robinette have some really nice results. So I think we can come up with a slide for each of those and get nice figures for each of those slides. And boom, we just described that and it's our press release.
Yep.
Nathaniel,
So, yeah.
I sent you an email earlier today.
Yes, I got it.
You got it. Did you look at the slide?
Did I look at the slide? The figure?
Yeah.
I looked.
I think it's a particularly good one. Now, you know.
Oh, the slide. Yes, I did. I started to look at that. I didn't get a chance to look at it super closely.
I thought it was a particularly good one, and so I sent it to you. That's
Yes.
all I wanted to do.
Well, I mean, we can bring it up really quickly here because I agree with that. It is particularly nice. So did I just go here and I hit here and there it is. So yeah, so it is. You get a nice, I guess this is the dawn here, and then there's the eclipse swing right there. Yes.
Yeah.
Very nice.
That's in just west of Tallahassee, Florida, about 30-40 miles.
Wow, that's impressive.
Yeah, that looks great.
Well,
So yeah. So we have some
the best one that there is, but it's the best one I know of. That's all I wanted to do, Nathaniel, is
Thank you.
you don't have to use it.
Thanks, Bob. Well, I think what we should do, I really like the one that Christina sent me, one that had data from the entire grape group this morning, which I thought was particularly good too. So this is not just from one grape station, but this is pretty much from every grape in the New England grape group is represented here. And I like this one a lot.
Well, that's a good one. The blue one though is I think is wait a minute, I can't see.
Yeah, we've got one from British Columbia in there. We've got Indiana, so we've got a good coverage.
Yeah.
I was about to say Ladysmith is a bit west, so.
Right. But
Okay.
I think, yeah. So I think the thing to do is to put together, update the presentation, put together a slide for each of the different projects, and then use those slides to make our press release.
Okay, that's all.
Yeah, that works. So
Great.
No, very good idea. I've got the notes and I've got the subject matter, and I'll collect that stuff as it comes along. I've got all the authors noted too, so. Okay, I don't know about writing a press release. We might need some help with that, but I can definitely get the images together and look at the standard presentation.
I'll give you a hand with
Well,
that.
Gary, I'll take a whack at it first.
Yeah.
Okay, great.
Yeah, because I kind of have in my head what I want to say on Tuesday. So I'll try and put that together, and I'll start doing the presentation first.
Perfect. Okay. Volunteer is always welcome. Okay, and obviously you got Ed's assistant too when it comes time to putting the thing out into the free world. So
yeah, maybe once I get the presentation together, maybe I can hand it over to someone to do the press release writing.
Yep, I can do the release for you. Yep, and obviously we could schedule this when we want to move it. So
Great.
okay, good. We got a plan of action. Excellent. All right, good. Let's see. I see Nick is here. We were just talking about the medium wave recording event. So Nick, if you want to bring that the one image that you had and some of the findings were pretty interesting.
Okay, I will share a screen and then see if I can find it, find the image. How about this one? Okay, here we are. This is the Eclipse from Fair Oaks, California, looking at a signal from KKXI in Snohomish, Washington, up near Seattle. And it's this one here. I don't know, can you see my mouse
Yes.
on the screen? Yeah, okay.
Mhm.
Okay, and you can see on the left side, 13th of October, 2023, this is the same signal, and this is the actual signal strength down here, and it just declines from sunrise, which is around 1400 13 UTC, which is up around here. It's finishing up here, and nothing much is happening after that. The signal just declines normally into daylight. On the 14th, you get the same sort of structure of sunrise, or similar structure of sunrise up to 1400. And then if you're looking at this, you can see that the red indicating a higher signal strength. The signal strength during eclipse maximum comes right back up, and this is actually the signal strength displayed down here. It's actually at peak, which is, I think, at 1630 UTC. Is actually stronger than it is at sunrise. The one thing that I found interesting is, what we're trying to do, one of the things we're trying to do is compare the effects of sunrise on medium wave signals to what happened during the eclipse. And you can see the extravagant sort of Doppler shifts and smearing and everything that goes on at sunrise up here. And there's really nothing much equivalent during the eclipse, at least at this location in Sacramento, on the Sacramento area. So anyway, yeah, any questions?
I think it looks really good, Nick. I think it's very convincing that you have the control day there, and on the left and the right you have the eclipse day. And I think it's very convincing to see that increase in the amplitude, and I also think it's very convincing to see the the changes in Doppler shift.
Yeah, I guess, yeah, as I say, or in this case, as far as the eclipse is concerned, the sort of lack of obvious change. I mean, there's, at sunrise, it's being, slashed all over the place. And, like there may well be a little bit of shift happening here, but it's not something that's obvious in this display. There's not enough detail to it.
But it is, I mean, it is, it's there are definite differences between the one on the right and the one on the left.
Oh yeah. But primarily they seem to be amplitude differences rather than frequency shifts.
Yeah.
But at least at first glance.
But we're also
again,
we're zoomed out a lot, right?
This is what we're looking at here is increments of let's see, this is about a hertz. So these stations are, or say these carriers are sort of over about I think it's 40 hertz across the entire screen there. So so you're looking at, like if there's a shift, it's in the sub-tenth of a hertz range. And it's not to say it's not there. It's just that compared to sunrise, it's not there.
Yeah. Would you be willing to work this figure up and put a little more information on it?
Okay. What sort of information? Like down at the bottom of it, which I can't quite. I can't move it on here on the screen. But I have, like where the eclipse starts, the maximum obscuration, because of course the eclipse isn't total at either of those locations, and the end of the eclipse. But like and the time of local sunrise. But what other information would you like?
Well, other things such as it'd be nice to have a frequency scale on there.
Okay, it is there actually. It's not on my display. It's actually at the top. I'm not sure whether I have access to it at the moment. Let's see. Yeah, but they're really, really tiny numbers, so I'd have to upgrade that.
Yeah. Do you
have? Sorry, go ahead.
Because I think doing things like that, like, and for now, I think for the quick look, for things I might show on like Tuesday night at the club meetings, it might be okay if you just took PowerPoint and you just use the words tool to write down, what frequencies there are, so that we have some idea that, okay, we're looking at 40
Okay, what
kilohertz.
exactly the scale across there? Yeah. Okay.
Yeah, scale. And are you able to identify what these transmitters are?
This one, KKXA, was quite possible because they actually identified themselves during the Eclipse maximum. The other ones, I'm going to have to take some guesses on, just judging on their actual frequency, exact frequencies. But yeah, I'll do my best. I mean, really, there are only 3 major signals there. I think a couple of these are actually spurious signals of some sort, but this one, and this one would be worth, sort of researching a bit more. Maybe I can use a QESDR or something like that to figure out if, like where these ones actually are, at least take a good guess at them.
Yeah.
What's the carrier frequency, please?
That was 1519.997, I believe. And that's kilohertz. So it's to the hertz, it's 997.
I thought these were medium wave.
That's correct.
So it'd be 1520 on the AM dial, as they say.
That's correct.
Okay.
Yes. Yeah. Mhm.
Okay.
Yeah. But as I say, the exact frequency of that, which is I thought was the question, was 1519.997 kilohertz.
Back when radios actually had a dial.
Yeah.
Bob remembers that. I know Bob remembers that.
Oh, absolutely.
Yeah. So any other questions? I'll see what I can do. Nathaniel, you need it by Tuesday, is that correct?
Yeah, I think if you could do it by Tuesday, if you were even to you just took this figure and you just took the PowerPoint tool and you just put some words on there to help say, okay, this is the frequencies that we're listening to. These are the stations we think they are. These are, just mark it up that way to give us that sort of context.
Okay. Frequency detail and stations. Okay. Yep.
Yeah, and even like locations of the stations. So
yes,
it says I have no idea where Fair Oaks is.
Yeah, it's near Sacramento, and that I would have to I would have to put that in. The individual in question is perfectly willing to have his name and call sign publicized to do with this. So I would do that as well, for personal interest.
Definitely.
Okay. So we'll do that.
And then you could put, slide, data collected by that person, then slide provided by your name, and that way you both get credit. Yeah.
Yeah, and I can also mention the software that was used to produce these figures. Which is making my life really easy.
That's good.
Yeah. Okay. I'll see what I can come up with over the next couple of days, and I'll send it off to you, and we can do some backing and forthing as to further details. Okay?
I have a HamSci PowerPoint template.
Is that the same one we were using for the Zoom talk that I gave? Yeah. Mm-hmm. Okay. I think I may still have that. If I don't, I'll get in touch with you.
That sounds great. Yeah. Okay. This looks really nice. Thank you.
Okay. Are we finished now? I can stop sharing. Okay.
I think so.
I think, Nick, did you use that template? You did a virtual talk at the HamSci workshop back in March too, right?
Yes. Mm-hmm.
Yeah, you should have a template from that possibly too.
That was the template I was thinking of. That I should have that on my machine somewhere, because I had to start somewhere.
Excellent. Thank you very much. It's good to see the results, obviously, from a variety of different projects too. That's a nice thing about it. Okay. I suppose maybe we should jump into, we have a couple of follow-up things from last week. I know, Nathaniel, you'd asked Mary Lou some comments or some questions about parallels between HamSci and project ideation and that sort of thing between the optical astronomy world and what we're doing here. with our science and stuff. So Mary Lou, do you want to speak on that for a few minutes? Are you ready?
Yeah. Can I share my screen? Let's see. Hmm. All right, so here I have a little slideshow. Some things that amateurs can do, certainly in optical astronomy. They design new equipment, they build experimental equipment, they build robotic telescopes in particular. Light pollution is a real problem for optical astronomy. So if you're on the East Coast, for instance, you have a telescope in your backyard that does very little, but you have another telescope out in New Mexico sitting on some mountain that you have rented a building to put it in. And you control it from your laptop here in New Jersey or whatever. And there's where your real telescope is. You monitor objects for changes in position or brightness. You can locate new objects, which is one of the great things that people like to do. Find new things, you get credit for that. People get their name on them. You categorize images that have already been taken by large telescopes. You can compute orbits. Amateurs can give to the project time, which is the major thing that amateurs have that astronomers of a professional nature do not have. It's time to do things like to follow up observations. They also have opportunistic schedules. So on spacecraft and major observatories, they do have the ability to call a target of opportunity. And so if you're observing something in your project and something goes off like a supernova, you are scratched for the night. Too bad. And and the telescope slews around to the new object. But astronomers of the amateur nature can do that right by their little selves. And there are alert systems, notifications that allow them to do that within minutes. And that's really exciting. Amateurs can also bring skills of all sorts, not only in astronomy, but also in computing and in writing and things like that. And they have location diversity, much more than real professional observatories have. So here's some of the motivations that we have found for amateurs. Some people really like partnerships and teamwork. They want to be part of a team. Here's a team that does asteroid occultation work. They want a place, after a couple years, you want a place where you can make a real use of some of your skills, not just making pretty pictures. You can get technical training of something that you are interested in or some new topic and you never had training in that before. People organize training sessions. You can get opportunities to speak and to publish, which otherwise an amateur astronomer sitting alone in their house in their backyard observatory doesn't often get. Many people are afraid of speaking and other people relish speaking. So that's something that sometimes people like. There are opportunities to interact with other people at conferences. You go to a conference or somebody takes you to a conference and you meet Neil deGrasse Tyson for the first time in person and shake his hands. Whoa, that's really cool, right?
I did that.
You did.
Thanks to Mary Lou.
Right, I thought of you. Okay. Types of projects in general. And I want you to note that in astronomy, there are many, many more astronomical objects in the sky than there are astronomers, professional and amateurs included. So there's plenty of stuff to play with if you want to find some particular niche. I'm not sure that is true in radio. But anyway, some of the objects that people do projects on are exoplanets, which are planets going around stars other than our sun, so other solar systems, asteroids, and we have hundreds of thousands of asteroids now in our solar system. And if you find one, you get to put a name on it. Doesn't have to be your name. You can honor somebody else. Ooh. There's planets, of course. We have 8 of those, and comets. Comets are fun to monitor. Variable stars. It turns out that 95% of the stars in the sky are perfectly steady. They have the same brightness forever and ever, as far as you can tell, at least in your 70 years. But some of them are variable, and sometimes they're cataclysmic. All of a sudden they vary. Others are variable in a more sinusoidal fashion, but they're fun to monitor. And then there are fate objects. people like to discover objects, and the ones that have not been discovered yet are all faint. So you go to for long exposures and you find something new. Kind of cool. So here's some exoplanet things. Some of them I've been involved in. Transit observations are when the exoplanet goes in front of its star from our viewpoint. And you could do photometry, which is to measure the photons, you measure the brightness. I was part of the KELT group from Lehigh University, part of the Kepler group, and now the TESS group I'm not part of, because our telescope, although it's big, doesn't have the signal to noise ratio of required for that. So one of the things that we found was, I thought was interesting, polluted white dwarfs. Nobody knew about these beforehand. Mario Mata is a physician in the Boston area, and he has a big telescope in his backyard, and got interested in planets going around white dwarfs, which are dead stars, and very, very faint at the end of their life. To get to a white dwarf, the star has to eject a lot of hot gas and should have burned up all its planets, but some of them nonetheless have planets. How did they do that? Nobody knows. But Mario is one of the people monitoring these things. And he and several other people discovered that some of them were polluted. I think, what the heck is that? Well, what happens is that what we think causes it now, what we know, is as a planet or perhaps an asteroid is orbiting this white dwarf star, there's a lot of friction from this gas that's been ejected, and the thing sloughs its way inwards and eventually falls onto the star. And when it falls onto the star's surface, it evaporates all of a sudden. And when it evaporates, you have a burst of darkness. So the star appears to have some sort of transit going, but it's very variable in a period of minutes. If you take a spectrum of it, we'll get to spectra in a minute. If you take a spectrum of it, you find all sorts of heavy elements like iron and copper and other metals, which bespeak the core of a planet, not the crust of a planet. So many of the asteroids are like that. So that's an interesting study. And Amateur Astronomers Incorporated is my club in Cranford, New Jersey. Jim Nordhausen there, one of the people there, has organized for a while a group of us to look at transits of particular exoplanets. Then one of the other ones I thought was interesting is the Panoptes project from Josh Wallawender at Keck Observatory out in Hawaii, and Olivier Gaillon from the University of Arizona, robotic photometry. So they have designed a system where you can build your own system, or they will send you a board partly built, and you put together a system of 2 small telescopes, 2 cameras, this analysis board, and robotic control. You set this out somewhere on a mountain or in your backyard, and it looks for transits by itself. They have maybe up to 5 or 6 people now with setups like this around the world. Then there's microlensing, which is something that amateurs do, hardly any professionals. You aim your camera and telescope at a rich field of stars, and you just let it run. And eventually you may find something that increases suddenly in brightness, decreases in a very certain way. And that has to do with general relativity. At any rate, this is one of the only ways to get the mass of an exoplanet, not just its momentum or its period or its size, but mass is very important. Then there's transit timing variations, TTVs. If you have a system of exoplanets where there's several of them going around the same star, then you can time their transits. And what you find is if 2 of them come near to each other, in reality, they change their timing sequence because they have had a gravitational interaction of each other. And this involves some heavy-duty computing, but people can then back off the masses of each of those planets. That's very powerful, but rare. Then there are asteroids. We have a ton of those in the solar system. It's easy, so they say, finding new asteroids. You just let your camera run and look for little tiny faint dots that move along. Determining their orbits is something rather more difficult, but people also do that. you need a sequence of pictures of this object over a period of several months, and then you can find out the preliminary orbit and then a real orbit of it. So the group IOTA, International Observations of Transiting Asteroids group, looks for the shapes of asteroids. And I think this was really interesting. So they have a database of the orbiter parameters for all, I don't know, 100,000 asteroids or whatever. And of course, we have databases of where the stars in the sky are, and they mix and match and occasionally come up with there's an asteroid going to pass in front of a star, and so there will be a shadow of the asteroid from the star falling on the Earth, and the asteroid shadow will be the same size and the same shape as the asteroid itself, because a star is at this point at infinity. And asteroids are about, as you see on the slide, 30 miles or 50 kilometers across, sometimes much smaller than that. So what you need is a dozen people, each with a small telescope, a camera attached, really good timing, timestamps, and you set them out in a place where the eclipse path is, or this shadow path is supposed to go. And if the shadow path is 30 miles across, then you try to have somebody every 5 miles along this path, and you just time it, and then the whole thing's over in 10 seconds. And then you go and drink beer for the rest of the night. But at any rate, they then send their timed data for, you see the star, you don't see the star, then you see the star again, to a group who does the computing. And here's the output of one of them. So this is the asteroid SEQP, which was thought to be one asteroid, but it turns out it's 2 asteroids really, really close together. So each of these colored lines, the diagonal line, is the report from a single person with a single telescope. And it's when it turns off, and then when it turns back on again, you can see the shadows of these 2 tiny asteroids. I think that's really amazing. Another thing that the IOTA group did is that they helped the New Horizons mission. This is the spacecraft that went off to Pluto some years ago and then went further on. They were lining up possible Kuiper belt objects, which are like asteroids but far beyond Pluto, that it could go to next. So there was some debate about a couple of them, and their asteroid or their orbits were not very well known, really. So these people took 2 18-inch telescopes. They took them apart, disassembled them, took them to South America, put them in the path of an eclipse like this of a couple of asteroids or Kuiper belt objects, sorry, and measured their timing, and then were able to help the mission decide where they wanted to go next. Another group looks for near Earth asteroids. These are potentially hazardous asteroids, and we do really want to keep track of where they are. Okay, in the solar system, we have some planets. Particularly, Jupiter has storms. Christopher Go in the Philippines has got a really nice telescope on an island with really laminar flow of air above it. And so he is supporting the spacecraft Juno, which is at Jupiter, as to what storms are coming up and where they should go look. Saturn storms have been discovered by amateurs as well. And then monitoring comets for their outbursts and their interactions with the gusty solar wind is another possible topic for people. Variable stars are sponsored, the very organized group looking at variable stars, the American Association of Variable Star Observers, AVSO. And there aren't very many of these, but they're always very exciting when they go off. So cataclysmic variables is one category. The one I like is supernovae. So it's a star that sits there for billions of years, minding its own business, and then one day it blows up. Cliff Ashcraft in the Cranford Club has been doing photometry of the one that went off early this summer in the Pinwheel Galaxy M101. So this particular graph shows time across the x-axis, brightness of the star going upwards, and the dots are different people's observations. The different colors bespeak different filters of color in front of the telescope. Cliff has no filter at all, but it turns out his teal colored big dots there match the green. So in effect, his telescope sees green light really, really well. And what we see is it took 1, 2, 3, 4, 5, 6 days for the supernova to get to maximum brightness, and then it's been fading off for several months now. And it's interesting that it's had a plateau. I don't know if you can see my cursor. There's the plateau in the middle there. And that plateau and then the break from it to go down says from models that we have of supernovae that this particular supernova is a type 2P, which means it has a lot of nickel 56 radioactive in its outer layers. Who knew? Okay. Then people do in general relativity during a solar eclipse, as was done in Einstein's day, 1919. People do spectra. Steve Lowe took this spectrum. What you see is wavelength, or color of light is horizontal here. The brightness of the star goes up there, brightness at different colors. And we see these dips, these very narrow downward extensions, and those bespeak different elements. He has marked off where hydrogen should be, and by gum, the star is doing hydrogen white where it should be. There's no Doppler shift in this one. The star is pretty well standing still relative to us. One can also do nebulae and the sun's corona, of course. So there are searches for faint objects. One of the things that software now allows amateurs to do is to combine many, many nights. So you take your telescope out, you have it look at a certain part of the sky, it tracks across the sky. You maybe get 4 or 5 hours and you go to bed or get up. And then the next night you do it again and again and again. And I was going to show you the picture, I couldn't find it, of the Squid Nebula, in which Tony took 45 hours of exposure on this one nebula and found a piece that had not been found before. And of course, one can use radio to look for pulsars, and some of them are optical as well. Okay, building equipment. A Schumann medial telescope is a real tough thing to build, but it's really very, very good once you build it. Batinel filters are not too hard. Robotic telescopes are kind of hard. So other things, people do categorization and analysis of images. There are big databases that NASA or Goddard Space Flight Center have. You sign up, they do your little training video about what to look for. You go through a couple hundred or 1,000 images and say, this one's got it, that one's not got it. And then they know where to follow up themselves. There's also outreach to schools and communities. This is especially fostered by NASA. They have a really organized system of solar system ambassadors where you have to take a course about the solar system. You have to respond to questions and whatnot, and then you get stamped with this. And then your name goes on a website, and clubs can call you up and say, would you like to give a talk? And these people love to give talks. And so excuse me. Anyway, and then another one that NASA has done more recently is outreach to undergraduate students at small colleges. And these are called the Eclipse ambassadors. And they have a training session and things like that. And then you get assigned a particular undergraduate student in your area, and the two of you go and give public talks to people. I don't know how that's gone, but it was really popular recently. I think techniques which are effective for amateur astronomers are training programs. So the NASA ambassadors have quite a training program. The AAVSO has online courses, and I've taken several of those. They're really good. They go for weeks and weeks and weeks, but you learn good stuff. And the Astronomical League has challenges that really are like mini courses that are, I think, well put together. University projects sometimes have outreach to people, especially in their area, but not necessarily anymore, to do real projects. And that's been good. And partnerships with groups like AAVSO or one of those. Their co-authorship of professional papers in astronomy and certainly in physics. There are now the possibility where you could have a paper authored by 100 people. So I mentioned Jim Nordhausen. He and 5 of his group are on a professional paper from exoplanets. And we're one of 105 authors of that paper. He was so thrilled, right? You can go to conferences. Sometimes now conferences, American Astronomical Society, will offer major discounts for amateurs to come and attend a conference rather. One of the things that I think is really very powerful is a registry for citizen science projects, which NASA has been doing great stuff with, and then a registry of speakers from these projects. And some people really are motivated to get their name on one of these registers. And that's the end. Okay.
Mary Lou,
Any questions?
I have a thing you might not know about. In the latest edition of the antenna book, the 25th edition that just started getting sold, there's a new section in the receiving antennas chapter about amateur radio astronomy antennas. That could be amateur radio astronomy or amateur radio astronomy. We haven't got that straightened out. Well, it's about 50-50. There's a whole bunch of.
So that's Sarah, right?
What's that? Sarah, right.
Yeah, I'm a member of Sarah too.
Okay.
Yeah.
And Rich Russell, who's running, he's the editor of the journal, put together a real good team to write a special edition of the journal that has all this information in it, and from which I extracted the material for the antenna book. And the special edition of the journal, I believe, is available from Sarah. It's not owned by the ARRL. So you might be able to see that online, and it's also distributed as part of the antenna books downloadable stuff when you buy.
Okay, so why don't you send us all or put in the chat the reference to that most easily?
Yes.
Thank you.
Yeah, that would be the thing. Yeah, it's a all the the antenna book is already out, so I can't change that, but kind of hard to go back and scribble at every copy, but ask Rich Russell, and he might give you the editor of the Sarah journal, and he might give you a direct link to it on the Sarah site.
Okay.
Because there's cool stuff in there, like just mapping the sky and discovering pulsars and all kinds of stuff. So you're in
Pulsars are difficult because they're exceedingly faint, so you need a big antenna. You need a real dish
or a lot of process
field of them.
Yeah. Well, these guys are finding them with single site antennas, but they're doing a lot of processing. So you do anyway. So check it out. You might find something interesting.
Thank you.
I saw a fair number of parallels in there between some of those projects and some of the amateur radio activities, remote ham radio stations, remote antennas, and that sort of thing too. Even some of the acronyms too, but that was quite a list, Mary Lou. A lot of food for thought. I mean, the other thing that interested me too is you talked about the alerts. Certain astronomical events will occur, and then people will go out and I assume observe them. I can see the same thing happening, from solar events someday. Whether it's whatever, when we get a little bit of a handle on what causes, say, TIDs, we can put out alerts, and then people can go monitor them and collect data sets, kind of on the spot. Because as you say, the professionals, you're in class, you're doing things that are important. And also retired and amateur folks can run out and do things sometimes on a minute's notice. So I could see that happening in the future too.
That's a very powerful thing to have the time flexibility to do that.
Mm-hmm.
Excellent. Good. Any other questions for Mary Lou? That was pretty darn good.
I really liked it, Mary Lou. Thank you so much. And I
The key is
think
to remember this recording. so you
I
can
think
refer to it.
as I watched, I think we are doing either we are doing or we are moving towards doing many of the things that were in that presentation in terms of things like, having people design instruments and analyze data and co-author papers and, work on presentations and, amateurs can collect data and be in places that I can't be. It seems like we are kind of doing, being very consistent with the same sort of, we're putting things in big NASA databases, a lot of the same sort of stuff.
I don't think, I have not seen yet, the training activities that I see in amateur astronomer. Maybe you have them, I just don't know.
No, I think that's true. I think they are not well developed right now. At least certainly not on the ham side of things. I don't think we have a good training and on-ramp system developed. We were talking a little bit about just documentation at this morning's meeting, and we were saying how Gary did a great job putting together this webpage for the Grape One digital RF, and he now does have documentation pretty much from top to bottom with one missing part, which we're going to be working on. But so we're starting to build up documentation, but you're right, we don't really have training videos or those sorts of activities the same way. And that's a really good idea to try to develop that.
Well, this was just a training activity here with Mary Lou's excellent talk, by the way.
Yes, and that's why we did this. But we don't have something like a solar system ambassadors program, and we don't have a section on our website that's like, you want to set up a Grape One, here's a video on how to do it. We've got the paper documentation. We don't have that sort of training. I think right now, one thing we're doing a good job of, I think, is these real-time telecons, and we're bringing in different people to give these real-time talks like this. So you're absolutely right, Bob. This is a type of training. We just don't have a formal program set up per se that's like standardized if someone wants to be trained on doing Grape One or something like that. That's not really there.
If I could add, Mary Lou, during your talk, you were talking about the dark sky or the absence of it. And we have the exact same thing, of course, in radio of the quiet location phenomena, and now the ability of the robotic telescope and the remote amateur radio station.
Yes, yes. Years ago, I had a Radio Jove set up on the science building roof. And in fact, Nathaniel actually used the Radio Jove setup at some point. And we discovered that, in fact, New Jersey is light polluted at all frequencies. So we invested in filters, and still it was a problem. You wouldn't believe how noisy and how poorly monitored is Radio Free Quebec.
Excellent. Well, thank you very much for that. This will be a recording the notes and come back to too. Hopefully you have a lot of good information there too.
So maybe I should find a picture of Jim and some other people and then send it to you, and you could put it on a website or something. I don't know. Whatever.
Yeah, the Hamsci site is rich with words, but not so rich with colorful images. We've definitely got some graphs and that sort of thing, but we're getting better in that respect. I'm sure. It's getting near 5. One of the things we wanted to bring up and was talk with Gareth a little bit too this week about some of the stuff that he may or may not have had time to pull out of the the ham side forum. I don't know, Gareth, if you're ready to do that, or if you'd rather, if the group's got time now, or you want to delay that for another week or so, that's your call, I guess.
Yeah, thanks for that. I'd definitely like to delay that for another week or so at least. So I mean, I haven't had the chance, but one of the things is as I don't want to say put it off, but the longer I wait or the longer it takes to get to it, the more that it's piling up, because just even just seeing all the emails come in and trying to comb through it. It's just, I was telling Nathaniel this, I think yesterday we had a chat, or 2 days ago now, how rich the topics are and how good the data is, and the plots coming out are just phenomenal. So it's, the longer I wait, the harder it is going to be for me, but yeah, we'll have to put it off.
I think in general, though, as a point of philosophy for this particular group, I'd like to see, certainly as we get towards the April eclipse, we absolutely want to keep, pushing forward with the logistics and the PR and all of that stuff. But I also want to make sure that this telecon starts moving over to more scientific analysis, and how do we actually analyze all this stuff and understand what we've gotten. I saw a comment come across the ham side listserv the other day that, they said basically, wow, you got all this PR, but now you need to analyze the data. Otherwise it's just stamp collecting or whatever. So, and I think it's a good point, and we really need to actually prove to that person that we are putting this eye in the ham side too. So yeah, but I believe we will, but just the, kind of where we want to think this group should go. So yeah, no, I think this is great. So thank you very much, Gary.
Yeah, no problem. Well, the interest is definitely there. And I mean, I can see what's happened with the grape. I mean, you look at the telecon this morning, there were about a screen and a half full of people in the Zoom call, which is easily twice as many as we had before the eclipse. So getting the grapes out there, people are getting interested. They're checking in, they're listening, and I'm sure the same thing will happen here once we start publishing the results. So that's fantastic.
And I think even though it's because I'm an astronomer, many people, even in the radio, are very visual learners. Make graphs, make pictures, make them colorful.
And
Well,
YouTube
that's
videos. YouTube videos
actually a
are
good
where it's
lead-in.
at right now. People do not read like they used to. What they want is a 3-minute video, 3 to 5 at the outside max. And don't try to get it all in one thing. Just say, hey, here's the overall picture, but here's the interesting bit. It's like car repair videos. They don't tell you this is a Subaru. They say, here's how to fix that stupid battery clamp. Don't ask me how I know that. And they focus on that. There may be 800 videos, but they're all short and focused. And that's what, if you're into the science of it, well, then you might want something more involved. But I think for the general audience, short videos that focus on one cool thing and punch it up. And as Nova has discovered, you have to have those sinister drums in the background, boom, 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 and then they'll pay attention to it. But at any rate, small things. If we can hook a couple of the YouTube makers to this, I think it would be to our benefit and everybody else's as well.
I
Yeah, if
agree
we
with
can get
that. And people like we can certainly make some of them ourselves, and we can also have like Jason Johnston help us out too.
Do interviews on some of the shows.
Yeah.
I should talk to Josh Naz. He's got Ham Radio Crash Course. Kyle AA0Z, who's in my E-Layer group. There's a bunch of them out there, and they're always looking for content. Gary, am I going to see you in the sweepstakes?
You'll see me there for sure.
I'll hear you. How's that? Yeah.
You hear me? Yeah, my signal, even with 100 watts, will probably be on par with your QRP signal, but that's okay. It's all about ERP, so.
There you go.
All about ERP.
angle.
That's CW sweepstakes this weekend, right?
Yes, this weekend. Yep.
Wow.
That's why the guys with the P shooter signals can get through on CW sweepstakes. I've never tried sideband from home. It wouldn't work.
I don't know. I got, when I was at grad student at Virginia Tech, I got a clean sweep from K4KDJ using 100 watts, with the club station. So on sideband sweepstakes. So we at least got a clean sweep.
Yeah,
I
yeah.
found with the call sign of Kilo Zulu 5 Whiskey Alpha back in the early 70s, the clean sweep was pretty easy with 100 watts.
Yeah, well, it's funny you say that too, because with CQ Worldwide last week, we were too short of DXCC on 15 meters. So that was a good day. Too short. So
Yeah, we came last weekend at Kilo Sierra 5 Zulu. We came within 5 to 10 of DXCC on most bands and 104 DXCC entries with all bands combined. 10 meters was amazing.
yep. Yeah, we did it on 15. So
Have fun, no
Didn't-
matter
didn't-
what you do.
we didn't score a lot, but we got 2 new guys who had never operated a contest ever before to make contacts. And then we helped less experienced guys get more practice. So we're growing contesters in Lubbock, Texas.
Good deal.
I
Good
like
deal.
That's what we'll be doing in 2 weeks at W0 E-Layer Contest Club, ECC. We'll have a multi-op, 6 ops, probably 3 are experienced and the other 3 are coming up to speed.
Nice. Hey, if we can take 1 more minute, I know we talked last week about potentially putting up or building a ham side flyer for use at Hamfest and club meetings and all that sort of stuff. Let me show something I threw together. So this here, the format of this, come on, pinch, is 8.5 by 11. That's for paper, believe it or not. So it's got our title, our name, and a QR code at the top. I wanted to say with mostly few words and a lot of pictures, as we've heard today. But I want to get the point across, especially after last week's call, that we are hams and scientists working together on scientific research. Now, Bill, who's on the call, had said maybe this should say ordinary hams because we really want to be very inclusive to a wide swath of people who can contribute. That's one possible change. But focus that, we do a lot of different things. We've got people who enjoy operating, people who enjoy building, programming, developing new technologies, and there's an educational component, which, as we said last week, is really bi-directional. Nathaniel's made that point in the past, that sometimes the scientists can learn from the hams, and sometimes it's the hams learning from the scientists. I kind of want to get that together in this third of the page. To give people a flavor for what we're about, a couple of recent projects with a little bit of graphics on there, and at the bottom, I can't see it because my Zoom controls are in the way. Learn more, join a project, subscribe type of thing. So this is what I sent out to a few people for comments last week on a flyer idea. If anybody's got some comments now or wants to send them to me, or I can bring this up again in the future or send it to anyone.
yeah, and we talked a little bit about using the reverse as a call to action, get people to sign up, how to learn more, those types of things. So
Exactly. If you got a piece of paper, you've got 2 sides, so why not use them both?
that's right.
So Ed made a good point there.
Yep.
I'd just say don't put ordinary in there. There's no such thing as an ordinary ham.
Maybe Nathaniel could use the Firefly app to generate some attractive backgrounds. Not kidding,
There you go.
Part it up, as they say. Make it.
It's not a bad
Wow,
idea.
what's that?
Yeah.
No, that's one of the things we talked about. The few of us that shared this thing is that we really need some graphic design work on this,
Graphic help,
because having an engineer doing graphic design is probably not the best thing in the world.
Yeah.
So, but anyhow, it gets the point across, I hope, and gives us some food for thought in the future. So,
Do you have another picture of a group of people hovering around a radio? They're not in white coats. I mean, that picture is good, but put the other picture on the backside with other stuff.
Right, yeah, the contact info and that sort of thing and whatnot. So you're probably right. That makes
Yep.
sense.
There was the picture on QST. I don't know if anybody really paid attention
Yeah,
to
just
it.
make sure you can see the wires coming out of the radio.
The radio, yeah, the radio with no antenna, no power.
Yes, that got edited online very quickly, but the paper was too late. It was too late. So anyhow, I just want to let you know that's at least coming along, and it needs some work for sure, but at least I think we've got to start anyhow.
Nice start.
It looks
Good, thank
really
you.
good.
All right, anything anybody else wants to bring up? Or 10 after 5, we're definitely over time a little bit, but we had a lot of very good discussion as usual today, so. Oh, we're good.
Thank you,
All right,
everyone.
thanks everyone for contributing. It's been good to see everyone again this week.
73.
73.
73.
All right, so long, all 73.